My name is Marshall Smith. I'm from NASA Langley Research Center, and I was the SE&I chief for ARES 1X. I came into the project initially a year after the project started. It was reformulated, and when the reformulation happened, they formed a mission management office. They actually formed an SE&I organization that encompassed the whole mission and not just the vehicle. And I came in as the SE&I lead for that organization. Prior to the reformulation of the project, SE&I was really focused on the vehicle, and then there was a ground part that was separate, and also down into each individual IPT there were SE&I elements as well. And so the coordination across different IPTs, as we had later in the process integration product teams, just wasn't happening as effectively as it could have. And so the reformulation really helped congeal that, put the SE&I in a single place. People still had SE&I in their organizations, but now they had an entity to look at that had more of a project focus rather than just a vehicle or a ground focus. When I came into SE&I, one of the first challenges that both Bob S. and I had is to try to pull the project together into a single entity. And one of the things that I felt like I needed to do was to get folks that were at other centers working at other IPTs integrated into SE&I as a project. So I actually brought in folks from KSC that were experienced in ground operations and the way they do things at KSC. Same at Marshall, put folks at Marshall that were integrators on parts of the vehicle, actually became part of SE&I. Glenn Research Center added somebody from Glenn Research Center, and as well as Johnson Space Flight Center. And so in doing that, I think it really helped Project see that we weren't trying to cause issues. We were actually trying to pull everybody together. When I came into SE&I, one of the things that really concerned me was the project was already a year underway, and it had a 3-year schedule to launch a rocket from scratch, to develop it from scratch. And I felt like we were already a year behind schedule, or almost a year behind schedule. We had requirements that needed to be really hammered out between the IPTs. Interface documents needed to be hammered out, and we're at the point where we should be building hardware if we're on this kind of schedule. Normally, a rocket takes anywhere from 5 to 8 years, usually closer to 8 years, to do from that point out. And although our rocket was technically simpler than some others, it was a test flight of a demonstration of some things, and so there was definitely some simpler things to do. There's no doubt that it was still a rocket. It was still, you have to touch all the bases, you have to check all the boxes, and you have to do all the analysis and all the testing, and it was a very daunting task. ARES 1X was critically important to Constellation. One, because we needed to take a team of people and pull them together and show that we can build a rocket, that we can process it, and do it successfully. Number two, we really needed to collect information about the environments that we needed for building the ARES 1 rocket. There were lots of questions out there. There were modeling practice and techniques that we just weren't sure. It's been 30 years since we've developed a rocket from scratch. A lot of great techniques out there, but how valid are they? So we wanted to get flight test data. We wanted to compare our flight test data to our test methodologies and our analytical methodologies to make sure that we really understood and were comfortable with what we were doing. And the test results showed that we in general were extremely good, but there was definitely holes and areas that we did not expect to find problems. And now that we know those things, that not only will that help the Constellation program, but it will also be a big benefit to vehicles in the future. One of the problems that I see the agency has is in dealing with how you make something more affordable, how you tailor things, how you go through accepting risk and doing things, is that some folks think 7120 is something that actually holds you down. It is extremely tailorable, and I think that people need to actually do that. If it calls for a document to be written, it doesn't mean you have to write a 300-page document. Sometimes a page is all you need to write. You're just really trying to go through the process to make sure that you've thought about what you need to think about, and that you've checked the box and you know that you've gotten that covered. Also in management, senior management, upper management needs to also, when things come to them, realize that they can't maintain control of everything. A lot of times people they have their pet little projects here and there, things that people want to really hold on to because that's their requirement. And people have got to realize that they've got to let that stuff go sometimes because it's just not going to accomplish the end goal of the whole mission. It's not going to allow that to happen. So affordability, tailoring, is a big thing that needs to be recognized and needs to be used and allowed to be used. One of the things that I came into the SE&I team, I had a very good team already there, already in place, people that knew their job and knew what they were doing. And when we brought in the other folks from the other centers, I put a lot of trust and really confidence and authority in those teams. So you need to have high quality people, first of all. You need to trust that they know their job and they're doing their job and they will get it done. And then when you do that, that breeds trust to the other folks. You can have a flatter organization, for example, because you know that the person responsible for part A is getting it done and he's getting it done right. The other part that you want to do is you not only trust that person, but you make sure that you have good independent verification and validation set up, IV&V, set up from the get-go. Everybody knows what we're going to double check, what we're not going to double check, and why, and where we're taking risk and where we're not taking risk. And you have worked out with the technical organizations responsible for these people that how they go about making sure they have a good technical product generated. And so once you have that set up, you can let the people do their job and not get in the middle. And when they give you an answer, maybe you don't like it sometimes, you know that it's right. You don't have to go revisit it. You don't have to go back and say, well, I just don't know. Let's do another option and another option and another option, which I see the agency get into quite a bit. We're done. It's time to move on. One of the key things that I learned from this project is that schedule really is king. That schedule really defines affordability. If you want to be affordable, you've got to have a schedule. You've got to have an aggressive schedule. That schedule needs to push the team, not to the breaking point, but push them so that they're going to do products. When they go do products, they don't have time. They have time to do them once, to do them right, to get the proper IV&V, to get the proper technical review, and you're done. And they're off focused on the next problem because there's a million problems. There's enough problems to deal with at once. And you don't have folks off generating yet another analysis just because they just wonder about this or that. You've done the checks. You know that they're good enough. And so that goes back to the good enough answer. We want to go do what's good enough. We don't want to do the best. We want to do what's acceptable, and we'll get the job done and make it happen. So schedule drives that immensely. And I think one of the lessons I would tell any new program is never say schedule is just going to be our slipping variable. I think that is a recipe for disaster. You're going to have your marching army, and it's just going to cost, and eventually you're going to have people who are bored, and they're going to end up doing things that aren't necessary and bring into things question, and then you'll never get there. One of the things that ARES 1X was very good about, and Bob S. Really pushed this along with the other IPT leads, is to stay focused on the primary objectives. You end up in a project generating requirements. You generate requirements, lots of requirements at system level, requirements for the IPTs, requirements for interface documents, etc. You get overloaded with requirements, and people have a tendency to focus on the requirement and do what they have to do to the nth degree to get the requirement met, and forget that the requirement was really born out of what are we trying to do? We're trying to fly a vehicle and prove that the vehicle flies properly and straight and we can control it. Or we're trying to show that we can assemble a vehicle, or we're trying to show that we don't have induced roll torque. Those are the things that we care about. And so one of the things that I and others really tried to push is that requirements are vehicles to help us meet those objectives, but don't let them get in the way. Don't make them the end-all, be-all of the project. If you have to change them, you have to change them, as long as we don't impact what our customer wants, which is to meet our objectives. And that I think is really key for any project in the future, is really settle in on what your goals are, what's your objective, and meet those objectives, and don't let the process bind you up along the way. One of the key things I learned about loads and environments is that anytime you build a new vehicle, you're going to be doing loads and environments up until the time you launch and after. Actually, as I got into it, I learned other programs out there, Atlas, some of the others, Atlas 5, I know they were running their loads the day they launched. They were running loads. So, I'm very convinced that it's never going to get better. It's always going to be uncertain. People are always going to be running loads. You're just always going to be saying, well, what if we did this? What if we did that? So you've got to understand it. You've got to accept it. You're building a new program. You're building a new rocket, and flow with it. Deal with it. Set your system up and set your people's expectations up that this is the way it's going to be. This is how it's going to happen. And everybody don't freak out about it. we're going to get it done, and we'll make it. And when you get to the end, it won't be a perfect solution, but it'll be good enough, and we'll have confidence in it to push the button and say go. One of the key lessons that I walked away with is that how you go about doing verification is really dependent upon a lot of times where the center and the culture has been. At some of the research centers and some of the places where you do fast-moving development verification, you do what we like to call product verification, where we actually go and we make sure that we look at the piece that was made for that part and we verify right then and there that everything's right with the actual as-built part. Basically, because it's usually a one-off, one-of-a-kind design, and you're moving forward. Production environments, say some of the space centers have been building shuttles for a long time, building the same boosters for a long time, etc. They have a little bit different mentality. They've set up a system, they do verification, they do DCMA comes in and they do verification where they get people coming in and just spot checking things, and that's good, and I have no problem with that. It works. But when you're building something for the first time for a new application, maybe something you're reusing, this goes back to heritage comments that I made earlier. When you're building something for the first time, you've got to actually realize that you've made changes. It's the first time you made the changes. You've got to spot checking those changes is not good enough. You need to make sure that you have verified those things are right, and it's not just been somebody coming along and checking drawing 10 of whatever. And so that was one of the things that we had a hard time with some of the IPTs and the mentality that some of us who built HyperX vehicles and things like that, one of a kind. And what our hard lessons learned have been in not checking everything for a one-of-a-kind vehicle. So we brought some of that, and so we had to grow. Some of the folks had to grow and learn to accept, those processes are good. They have been in place. They're very, very talented people working those systems. On the other hand, I think some of the space culture needs to realize we're not building production systems anymore. These are one-of-a-kind systems, and so we need to make sure we need to do a little deeper checking in some cases. Most projects follow a traditional process where you have design verification, a design analysis cycle that you end up at CDR. You do a design verification, and then if you're going to do production, you just go build it, and you just always go back and check against that design verification. Okay, the drawing says this, and so people are real into making sure the drawings are perfect and making sure, which is a good thing. You want to do that, but in our case, and especially when you're moving fast, you're doing development flight testing. A lot of times the hardware design is happening almost in parallel with some of the hardware being manufactured. And so to have a true design verification, it's really difficult. And that happens a lot in the flight test and development, world. So that's why you end up going toward more of a product or in-product verification, because you've got to make sure that the thing that was built is exactly is what we expected it to be in the analysis. So when I'm looking at my thrust vectoring system and I expect a certain nozzle to have a bias of so many inches in my model that I just finished building, probably 5 months after the product process was built, and you might have to go back and not just check the drawing, but you really need to go back and look and measure and see what it really is, so that you can put that make sure that your analysis is correct. One of the key things I would like to take forward to new programs is the importance of flight test. NASA, Mercury, Apollo, Gemini programs all were really heavily flight test dependent. There were numerous flights all along the way. There were test flights, each building upon the next and the next. And I would highly encourage any program that we go and build to have that philosophy, because one, it allows you to solve problems, it allows you to get the team going, it allows you to solve problems and actually put an end to some of the questions. Many times people would say, well, I just don't know. And once the flight test was over, there was no discussion anymore. It was done. You updated the model. Either side A or side B was right. Everybody was happy. We knew how it worked. And so a flight test, what it does is not only solves the problems that you think you're going to have, but it tells you a lot of unknowns, things that you didn't expect. You find out things you didn't expect. For example, we had an issue with the parachutes. And the issue really stemmed from how we packaged it in this one-time environment. But we learned something about parachute equation that the folks at Marshall Space Flight Center are going back and going to make a change to how we design and analyze parachutes in the future. That's an area we didn't expect to learn. Another area, for example, is how we were doing our thrust tail off. At thrust tail off, we were having something called slag come out and provide extra thrust, if you will, to the vehicle at a time when you don't want it. You're trying to stabilize and do a proper separation. And so we didn't expect to learn about this process, but what we did learn is that we need to account for it, and if we were to continue on the ARES 1 program path, that we would have to deal with that. Nobody really thought much about that prior to the test. So not only do you learn the things that you expect to learn, but you end up learning a lot of things you didn't expect to learn, and sometimes they really will save your bacon in the end. And that's the process that you go through. And so I would personally highly recommend you set up a series of test programs, each building on the next, similar to what we did in the past. I think they had it right, and that's the right way to go. With any flight test, there's a desire to have a lot of development flight instrumentation. When the project started, there was a requirement to have something like 2,000 sensors on the vehicle. And the bottom line is it cost a lot of money. And more importantly, which is really equates to money, it cost a lot of time to procure, integrate, design, actually install, calibrate, and test, and then you have problems with them and how you deal with them. It's just a tremendous amount of time. So you've got to balance, every program's got to balance the need for data versus the need to get the job done. And so we struggled, and every program's going to struggle with this, is what that line is. And so you've really got to be, one thing I learned is you've got to be a little ruthless sometimes and make the folks who want the data really decide what they absolutely have to have. And you might have to have 2 or 3 sessions of what you absolutely have to have, because in the end you get done. We got fantastic data, and there are probably only 2 or 3 places, they're very minor places actually, where somebody said, well, I wish we'd have had a sensor here. Okay, we probably would have in the original configuration, but I would say 99% of the data we took was more than adequate to do the analysis we needed to do. And even so my lesson learned is we pushed hard, we got it down to what people in a lot of cases felt was unacceptable, but in the end the data was great, and they're very, very pleased with what they have. Sure, would they like to have more? Yeah, everybody like to have more, but we proved that we can do it, and we can validate our models and move forward. One of the things ARES 1X was able to do is to show flight test data and coupled that back with our analysis and our actual ground testing that we've done in wind tunnels, etc., and see where we had holes, see the things that not only for ARES 1X but any future vehicle would have. For example, in vibroacoustics, we've been doing vibroacoustics a long time. We think we're pretty good at it, but the reality is that in some areas, in general, we were predicted our vibroacoustics across the whole vehicle in general, and in some places quite a bit, 3 to 4 times in some places. The sound pressure levels were higher than expected, and so those are really big misses. And that data needs to be transmitted not only to us but to industry, because it's not ARES 1X specific, it's geometry specific, it's whatever some company is going to build. They need to be able to look at this data and go, gee, I don't think this is what I think the analysis is telling me, but I really, whether I want to or not, and I usually don't, need to probably add 3 or 4 dB to cover this unknown, because in general we're going to find that it is higher than our current modeling capabilities are giving us. And that happens across the board. It happens in how we go about doing our structural analysis, how we go about doing our thermal analysis, and other areas. We found holes here and there, places where models just weren't right. And those models are not only used for ARES 1X or ARES 1 or ARES 5, they can be used for other vehicles as well. When I came into the ARES 1X job, my previous history had been working in aeronautics. Most of my career, I had changed over to the spaceflight world and been working in ARES 1 for Langley, how we interface with the ARES 1 team, and also science mission side of the house. So I had some diverse experience, but I felt really unprepared for the SE&I job when I walked in, and so I was definitely uncomfortable. I had a systems knowledge. I felt like I could do that, but I've not done rockets particularly in the past, and so one of the things I had to learn to do, and it was kind of easy for me because I didn't have the knowledge, is I had to know that the guys around me and the ladies around me really did know what they were doing, and you have to trust them, and you'll get up to speed quickly, and you study, you spend unreal amounts of time, studying, learning the systems, learning what you got to do, learning what needs to be done, learning everything about each individual system to as low a level as possible. and asking questions, and not being afraid to ask the what you might think is the dumb question to the guy who's been doing it for 30 years. And he knows you just started, and he's happy to get you up to speed. And, within 3 to 6 months, I felt like I was fully engaged. I understood exactly where I was and what needed to be done, and how to get it done. And so I would encourage anybody stepping into a role like that to, don't be afraid, jump in the deep end, and start swimming, and realize there's a lot of people around you who are riding their boats, and they can pull you up anytime you say, give me a hand.